Hey audience, let's see this question of Irodov. It's question of hydrodynamics, again involving concept of variable mass thrust. This question number is 1.328. Question states, water flows out of a big tank along a tube bent at right angles. The inside radius of the tube is equal to small r. The length of the horizontal section of the tube is equal to small l. The water flow rate is q. Find the moment of reaction forces of flowing water acting on the tube relative to point O. Moment means the torque due to the force of reaction about O. That's what we have to find. Alright. So this is a slightly bigger diagram. The water is coming out, suppose, with velocity v. And this velocity will be same throughout all section because area is same everywhere. And the area of the section is everywhere is pi into small r square. Small r is the radius. So volume flow rate at each section is q is equal to area into velocity. And now if I take any part, any straight part of the pipe like this, if I can take this part or I can take this part. So here water enters and here water leaves. We know that F thrust is equal to V relative dm by dt. dm by dt is mass flux in the how much mass is crossing per time, and this is basically rho times of AV, and this V relative is V. So F thrust is rho AV square. And from the above equation, F thrust is along V relative dm by dt is positive. So here mass is entering, so F thrust will act in this direction. And here mass is leaving, so F thrust will act in this direction. So net force on any straight part would be 0. There could be net force if the area changes, but here V is same, A is same, so there will not be any net force if the area is same, and if the area is same, so velocity will be same. So neither on this part nor on this part. So here on this part where the pipe bends, so there will be net force, and if there is net force, so there could also be net torque about some point. So let me take this section. This section, I am taking this section of the pipe. Here water enters and here water leaves. So I just written thrust force, magnitude of thrust force at each section is rho A into V square. So here, because water is entering, thrust force will be in the direction of velocity. So thrust force will be in this direction. I can just, because it is a vector, I can just extend it. So that is a F thrust here. And here it is leaving, so F thrust will be in this direction. So the net force would be somewhere here, but it is better to keep it like this. And we have to find torque about point O. So torque about point O, clearly because of this part of thrust force, torque would be 0 because line of action of the force is parallel to the position vector. So because of this part of F thrust, there would be this anti-clockwise direction torque, and the magnitude of this torque would be R times, R is basically L times of F thrust. F thrust, and F thrust is rho AV square. F thrust is not the net F thrust. F thrust is on this part. So if the resultant you want to take, that would be root 2 times of that. So this F thrust. So what we can do, we can multiply this on the numerator denominator by A. So that would be rho A square V square divided by A. And AV is Q. So this would be rho Q square divided by A, and A is pi R square. So I can put it this F thrust here, so it would be rho L Q square divided by pi small r square. That would be thrust force. That would be torque due to the thrust force above 2.